Morning students. Yesterday we are learn mathematics second chapter mathematics second chapter parallel line that we are completed. Today we are going to learn maths 1 chapter number 2, that is the real number. So we are start the real number, but before starting the real number we can see something which is necessary to understand the real number or to solve the practice set 2.1. So what will be the requirement of basic knowledge that we can see the first. So this is the name of the chapter is the real number. So here is you can see the screen and you are learn from standard 6 to standard 8 also. So first we are learn that is a natural number. So natural number is denoted or it is indicated by the capital N. So this N means natural number. So then N is indicated the set of natural number. So the natural number is started from 1, 2, 3, 4 dash. Okay. So this is the natural number and that is started from 1, 2, 3 dash. So this is called as the natural number. So the natural number is infinite. We cannot know the last number of the natural number, which is that. Then we are going to see the whole numbers, set of whole numbers. So set of whole number is indicated by W. N indicate the natural number, remember that. And W means whole number. Whole number is started from 0, 1, 2, 3, 4. Okay. So after natural number the whole number can be find out. After that we are indicate some negative things. So for indicating the negative things we are required the integers. So I is the set of integers. I is the set of integers. So integers can be denoted by this is the whole number and opposite of the sign of the whole number together is called as the integer number. See, whole number 0, 1, 2, 3 dash. Then opposite of this 1, positive 1 it become negative 1, positive 2 it become negative 2, positive 3 it become negative 3. So this is the whole number, that is the positive whole numbers, and this is the negative numbers, integer numbers. So positive and negative integer numbers together is called as the integer numbers. The positive numbers and negative numbers together is called as the integer numbers, and that integer numbers can be indicated by I. Okay. Then we are see the set of rational number. What is the meaning of rational? Rational means suppose the number is indicated by P upon Q, means such a way in the numerator and denominator form. See, P is the numerator and Q is the denominator. Okay, but if the denominator Q is equal to 0, then it is irrational number. It is not a rational number. But if denominator Q is not equal to 0, see here is they are showing the Q is not equal to 0, then it is a rational number. It is very simple. See, P is the numerator, Q is the denominator, and Q denominator is belonging to integer numbers. So that Q is if 0, then it is a irrational number. But if Q is not equal to 0, then it is the rational number. So denominator never 0, then it is rational number. So then R is the set of real number. So set of real number means what? Real number means rational number and irrational number together is called as the real number. So remember that real number means rational numbers and irrational number together is called as real number. Are you understand what is the real number? Real number means rational number and irrational number together is called as the real number. Are you understand? Okay. Then this is the real number indicated by capital R. So natural number is the subsets of whole number. Why would it say that? Because natural number is started from 1. So all the numbers from 1 they are having in whole number. So natural number is subsets of whole number. So whole number is 0, 1, 2, 3 dash. This is the 0, 1, 2, 3 all positive numbers. So this all positive number is having in integer numbers. So the whole number is the subsets of integer number, because in integer number they are having the positive number as well as negative number is there. So they are subsets. Then integer number is subsets of the rational number, because some of the integer numbers are rational, that denominator is not equal to 0, so it is the rational number, and some is denominator is 0, then it is a rational number, indicates, because rational number means denominator is not equal to 0, so q is not equal to 0, then it is rational number. And if when q is equal to 0, then it is irrational number. So rational and irrational together is called as the real number. So q is the subsets of, means rational number is subsets of real number. Why rational number is the subsets of real number? Because all the real number means rational and irrational number. So all the rational numbers is having in real number, so it is the subset. So if you are observe, then what you think that the real number is the universal sets of all numbers. See why? Because natural number is subsets of whole number, whole number is subsets of integer number, integer number is subsets of rational number, and rational number is subsets of real number. Real number means number is rational and irrational. Okay, this is the sequence. Then decimal form of the rational number. The decimal form of the rational number are two types. One is the terminating type and another is the non-terminating type. Terminating type means number is divided. If two numbers divides, then that remainder is 0, then it is terminating. And if your remainder is not 0, then it is non-terminating. Means when you are doing the divide process and remainder is 0, then it is terminating. And when you are doing the divides process and remainder is not 0, then it is non-terminating. So there are the two types of decimal form of rational number. So two types of the decimal form of rational, one is the terminating type, another is the non-terminating types. Okay, then that examples can be shown here. Terminating 4 upon 5. So this 5 is divided to 4. So we are in 9th standard. So I think that you are easily understand the divides. 5 divide 4 is not possible. So what can we give? 5 0 0. So here is 0 question. Then I will give here a decimal point. So when I give here a decimal point, then here is 0. So its number is become 40. So 5 8 40. So you are getting 0.8. 5 8 40. So remainder is 0. So it is not possible to divide ahead. So 0.8 is the terminating. Okay, terminating, because remainder is 0. So we cannot divide forward. So it is terminating. Then 17 upon 8. So 8 is divided 17. 8 2 are 16. 17 minus 16. What is remain? 1. 8 2 are. So here is 2. Then 17 minus 16, 1 is remain. Decimal point. See, this decimal point is given. So 1, there is given 0, it become 10. 8 1s are 8. 10 minus 8, what is remain? 2. Again taken 0, 20. 8 2s are 16. So 20 minus 16, what is remains? 4. Again take 0, it become 40. 8 5s are 40. So here is remainder is 0. We cannot divide forward. So it is terminating. 2.125 is terminating. Then 45 upon 6. We want to divide it. 6 7s are 42. 6 7s are 42. So 45 minus 42, what is remains? 3 is remains. Then decimal point. Then it become 30. So 6 5s are 30. So it remainder is 0. So it is terminating 7.5. So these all examples are terminating because there is remainder get you 0. You cannot divide forward, so it is terminating. 4 upon 5 0.8, to 17 upon 8 2.125, and 45 upon 6 7.5. These are the terminating example. Then we are going to see the non-terminating recurring form. So what is the recurring? Recurring means after decimal point if same number coming again and again and again, then it is called a recurring. So there is number is coming, and another way there are coming the number of groups such a way. See, this is the group, that group are coming again and again. So recurring means after decimal point this number is coming again and again, that same number is coming again and again, so it is a recurring. Or another way, recurring means the group of number. See, it is very simple to understand, so I am showing that the group of number 58333, that group of number is, here is the 33 is coming again and again, so again here is single number 3 is coming. But if you are observe this 2 8 5 7 1, okay, 7 1 4, after that again this same condition is coming again and again, so group of number is coming again and again, then it is recurring. Are you understand? Non-terminating recurring type. So 1 upon 3, 3 is divided to 1, so first it is not possible, 3 0 0, so it is 0, decimal point, so here you can take 0, it is become 10. 3 3s are 9, 10 minus 9, what is remain 1, again take 0, 3 3s are 9, 10 minus 9 remain 1, again take 0, 3 3s are 9. So if you are process doing again and again, you are getting remainder 1 and quotient you are getting 333. So it is the non-terminating, because here is not get remainder 0, so it is non-terminating. Recurring, why it is recurring? Because same number coming again and again, so it is recurring. Then 2 upon 7, so this 7 is divided 2, so 7 table 2 is not, so 7 0 0, so here is first quotient is 0. Afterwards I will give here decimal point, so when I give here decimal point, I write here 0, so it become 20. 7 2 are 14, so 20 minus 14, what is remains 6, again take 0, 7 8 are 56, 60 minus 56 4, 0, 7 5 are 35, so what is remains 5, 0, 7 7 are 49, what is remains 1, 7 then 0, 7 1 are 7. So this is the divide process. You can divide 7 to 2. I think that you are easily divide it, because divide can be you learn from 4th standard to 8th standards also. So that divide you can only simply do the divide. 7 is divided to 2, you are getting that answer, and that is non-terminating, because remainder you are not getting 0, so it is non-terminating. And number of group, this is 2 8 5 7 1 4, that is coming again and again, so it is recurring. Then 12 is divided to 7, so 12 0 0, decimal point, it becomes 70. 12 5 are 60, 70 minus 60, what is remains 10, so here is 0. So if you are divide this, then you are getting 0.58. The 3 is coming again and again. Such a way it is non-terminating recurring from. Then this is the example. What is given here? 3 upon 4. Here is and 2 upon 5. These examples are coming for exam. Which number is greater? 3 upon 4 is greater or 2 upon 5 is greater? Here is substitute the value, because here is solve. But when this question is coming in exam, then that is written such a way: 3 upon 4 comma 2 upon 5. Write down the relation between these two numbers. Relation means you can write whether that number is bigger number or smaller number, then which number is greater number and which number is smaller number, that you mention here. Okay, so how can you mention 3 upon 4 is equal to 2 upon 5? We are doing the cross multiplication, 3 into 5. This is the first multiplication. So if the first multiplication is greater, then first number is greater. If the second multiplication is greater, second number is greater. So first multiplication, 3 into 5. So I write here 3 into 5. Another 2 into 4. So I write here 2 into 4. 3 5s are 15. 2 4s are 8. 15 is greater than 8. So 15 is greater than 8. So first now a multiplication is greater, so 3 upon 4 is greater than 2 upon 5. Then another 1 upon 5 and 2 upon 3. So there is also a relation, which is the greater. So see, 1 is multiplying 3, so here is 1 is multiplying 3. Then 2 is multiplying 5. 3 1s are 3 and 2 5s are 10. So 10 is greater, okay? 10 is greater. So 10 is greater. So second multiplication is greater. So second multiplication is greater. So here is 2 upon 3 is the bigger number. So that is the rule. It is written here: P upon Q is equal to R upon S if PS is equal to QR. So that example is also here. See, this is the P upon Q is equal to R upon S. When we are say equal, when multiplication of PS means first numerator and another denominator, multiplication of PS is equal to multiplication of QR. Here is written PS is equal to QR. Then these two numbers are equal numbers. So here is 3 upon 5 and 6 upon 10. 3 is multiplying 10. So 3 is multiplying 10. 10 3s are 30. Then another number 6 into 5. So 6 into 5 or 5 into 6. So what can you get? 5 into 6, 30. So 30 30 both sides are same, so they are equal. Okay, such a way this is the rule, and according to here these numbers, and after comparing this number, which number is equal? If PS is equal to QR, then they are equal. If PS is greater than QR, then first number is greater. If PS is smaller than QR, then second number is greater. Such a way, this is the relation between them. Then we will start the practice set 2.1, question number 1 and 2. So what is the question number 1? Classify the decimal form of the given rational number into terminating and non-terminating form. So terminating means if you are get remainder 0, then it is terminating. Remember, if you get remainder 0, only you are kept in your mind, if remainder 0, then it is terminating. If remainder is not 0, number after divide process is continuously, then it is non-terminating. Simple to understand. If you are get remainder 0, it is terminating. If remainder you are not get 0 that are continuous, then it is non-terminating. Okay, so recurring means I already explained, after decimal point, if same number coming again and again, or number of group coming again and again, then it is called as the recurring decimal types. So see, 13 divided by 5. Okay, 13 divided by 5. So 5 is divided to 13. So 5 2s are 10. 13 minus 10, what is remain? 3. Here is decimal point 0, 30. 5 6 are 30. So 13 upon 5 is equal to, you are getting 2.6. So here is you are getting remainder 0. So it is terminating. Do you understand? Because 5 6 are 30. Remainder is 0. So it is terminating. So this is terminating. Then see, 11 divided to 2. 11 divided to 2. So 11 table 2 is not coming. So 11 0 0. So here is first question 0. Then decimal point. So here is take 0, it become 20. 11 1s are 11. 20 minus 11 1s are 11. So here is 1. 20 minus 11, what is remains? 9. Again take 0, 90. 11 8s are 88. 90 minus 88, what is remain? 2. Okay, then 0. 11 1s are 11. Again remains 9. 11 8s are 88. So if this process you are doing divides again and again, then you are getting 8. You are getting 2 remainder again and again. You get 2 remainder, and question is coming 1818 again and again. Mean this is 18 is the recurring types. It is the non-terminating recurring. Non-terminating, why? Because there is the remainder you cannot get 0. So that can be shown by dotted line. Dotted line means here is 18 coming, 18 coming, 18 coming. So it is non-terminating. And recurring, why it is recurring? It is recurring because after a decimal point, the 18 number coming again and again, and remainder to remain as it is. So this is simple to only divides. So I am not sure. You can solve this problem when, then you can show by divides. Means 5 is divided to 30. 11 is divided to 2. Okay. Then problem number 3. 16. 29 upon 16. So 16 is divided to 29. 16 1s are 16. 1. So 29 minus 16, what is remain? 13. So here is decimal point 0. It become 130. So 16 8s are. So that is the 128. Then 2 is remain. Again 16 1s are 16. Such a way we are divides. Then last we are get 16 5s are 80. So here is remainder is 0. So it is terminating. So 29 upon 16, that divide is the terminating, because here you get the remainder is 0. Then another problem. Problem number 4. 17 upon 125. So this 125 divide to 17. Okay. This 125 divide to 17. So 125 table 17 is not coming. So what can you do? 125 0 0. So here is 0. Then decimal point. So here is you take 0. It become 170. 125 1s are 125. So 170 minus 25 you are doing. So here is again take 0, and you are doing this divide, then you are get remainder 0. So it is also terminating from. Then 11 upon 6. 6 is divided to 11. 6 is divided to 11. 6 ones are 6. Okay, sorry. Here is 6 ones are 6. This is the wrong answer you are getting. You show your divide process. This is the wrong answer. By mistake written. So please you are do it correctly such a way. 6 ones are 6. 1. 11 minus 6. What is remain? 5. The decimal point 0. 6 8s are 48. 2. Such a way. This is non-terminating. You can solve and find out. If you are get here remainder 0, it is terminating. If you are solve and not get remainder 0, it is non-terminating. I again say it is the by mistakenly wrong, so you can write it correctly. Then this is the question number 2. Write the following rational numbers in decimal form. So you want to write the rational numbers into decimal form. So 127 divided by 200, 25 divided by 99, 23 divided by 7, 4 upon 5, so 17 upon 8. So that's all right into the decimal form. So see, 127 remain as it is. 200 can be divided, means 200 can be factorized 2 into 100. Okay, 127, 2 cannot be divided 127 because it is the odd number. 7 is the odd number. So here is 2 is 200 is showing here 2 into 100. 2 into 100. So you get 200. Then what can be done? See here, 2 is divided to 127. 2 6 are 12. So here is 12 is cancelled. Next 2 3s are 6. 7 minus 6. 2 3s are 6. So 63. And then decimal point. 2 5s are 10. So 63.5 divided by 100. So here is 63.5 divided by 100. If someone don't understand, then I will explain it into Marathi. See 127 आहे, त्याला डिवाइड्स करायचं आहे 200 ने. आता तिथे हे आहे ते विषम संख्या आहे आणि ही समसंख्या. मग आपण काय करूया, 2 ने 127 ला डिवाइड होत नाही. होय, आपण म्हणजे केलं तर कसं येईल, बेसक 12 6 राहिले, 1 घेतला वरून, बेत्रिक 6 63 झाले. डेसिमल पॉईंट. then 2 5 are 10. So this 200 is factorized here 2 into 100. Okay, then that 2 या 2 ने 127 ला डिवाइड केलं. बेसक 12 6 आले, बेत्रिक 6 3 आले. मग इथे डेसिमल पॉईंट दिला, 7 मधून 6 गेले, 1 राहिला, 0 आला, बेपंच 10, असं 63.5 झालं. डिवाइड बाय 100 हे आहेतच. मग 1 वरती किती झिरो आहेत तेवढा डेसिमल पॉईंट पुढे जाईल. तर 1 वरती आपण बघितलं तर 2 झिरो आहे, म्हणून हा जो डेसिमल पॉईंट आहे तो 2 डिजिट्स पुढे जाईल, 1 आणि 2. मग आन्सर काय आलं, 0.635. ओके, आय मीन एक्सप्लेन इनटू द मराठी. Then if English, 127 divided by 200, so 200 can be factorized 2 into 100. So this 2 is divided to 12. 2 6 are 12, so 6. 2 3s are 6, so 7 minus 2 3s are 6, so 3. Decimal point. 7 minus 6 1. After decimal point, this number will become 10. 2 5s are 10. So here is 2 zeros. So decimal point go 2 digits ahead. So here is 0.635. That is the answer. So 25 upon 99. So 99 is divided to 25. Simple. What I say, remember, 95 is divided to 25. You can do the divide there. 95 divide to 25. So we are getting that answer 0.25. Then 25 coming again and again. So it is non-terminating recurring form. Non-terminating recurring. So you are right, 0.25. Here is you can show the bar. Such a way you are making here a bars. So another problem is there. 23 upon 7. See, 23 upon 7. So 7 is divided to 23. 7 3s are 21. 3. 23 minus 21. What is remain 2? Decimal point. 7 2s are 14. Such a way you are getting. See. 7 3s are 21. So here is 3. So 23 minus 21. What is remain 2? Decimal point. Here is decimal point. On 2 there is 0. 7 2s are 14. 20 minus 14. What is remain 6. 0. 7 8 are 56. What is remain 4? 0. 7 5 are 35. What is remains 5? Such a way, if 7 is divided to 23, so when you are divide the 7 to 23, then you are getting this answer. But in that answer 2 8 5 7 1 4. So this group can you get again and again you. So it is a non-terminating recurring form. All of my students, you must be divided. Okay, 7 is divided to 23 in your notebook and write the answer. So you are not get remainder 0. So you are not get remainder 0. So it is non-terminating recurring form. Then we are going to solve. This is the answer written. On this answer there is the, you can draw the bar. Here is you can draw the bar. Okay, such a way bar, because this group is coming again and again. So non-terminating recurring form. I think so there is showing the bar here. See, on 25 they are also showing bar, because this 25 are coming again and again. Afterwards 2 8 5 7 1 4, that is coming again and again. So there is showing bar, that means that it is a non-terminating recurring form. Then 4 upon 5. So 5 is divided 4. 5 0 0, because in the table of 5 4 is not coming. So 5 0 0. Then give decimal point. It become 40. 5 8 are 40. So 0.8 is the answer. So see here 0.8 is the answer. What they are doing, 4 is kept as it is. Which number multiple 5? Then you get 10 2. So 5 into 2. If denominator multiply by 2, then numerator is also multiplied by 2. 4 2 are 8, so here is 8. 5 2 are 10, so 8 upon 10. So how many 0 having on 1? 1 0. So decimal point 1 digits back, so 0.8. So some of the students have doubt why you are multiply here 2, because we want to convert it into 10. Why 10? Because you write answer in the decimal form. This is the one of the method that 5 is multiplied by 2. So if 5 is multiplied by 2, then 2 is also multiplying 4 into 2. 4 2 is 8, 5 2 is 10. So 10 is divided 8. So first we write here 8. On 1 how many 0? 1 0. So 1 decimal point back 0.8. ही एक पद्धत आहे. दुसरी पद्धत अशी आहे की 5 ने सरळ 4 ला भागायचं, डिवाइड करायचं. 5 0 0 decimal point. Decimal points it become 40. 5 8 are 40. So you are getting such answers. Anyone doubts? Then 17 upon 8. So see here 8 2 are 16. 8 2 are 16. 17 minus 16, what is remain? 1 decimal point. 8 1 are 8. Such a way here is divide. See 8 2 are 16. So here is 2 decimal point. 17 minus 16 1. It becomes 0. Means tens. 8 1 are 8. 10 minus 8 2 0. 8 2 are 16. 20 minus 16 4 0. 8 5 are 40. So you are getting 2.125. हा डिवाइड केला आपण 8 2 16. 17तून 8 2 16 म्हणून इथे 2 दिलं. 17 मधून 16 गेले 1 राहिला. डेसिमल पॉइंट दिला म्हणजे 10 झाले. 8 1 8. 10 तून 8 गेले 2 राहिले. त्याच्यावरती डेसिमल पॉइंट झाला तर 20 झाले. 8 2 are 16. 20 मधून 16 गेले राहिले 4. 8 5 are 40. So you are getting 2.125. Such a way we are solve the question number 1 and question number 2. So whether you are understand or not understand, that can be checked with help of homework, and that homework is given to you. So you can solve this homework and send me on my WhatsApp numbers. And stay home, stay safe, and if you like this channel, subscribe it. If you are subscribed, if the student who is not subscribed, subscribe this channel, and the students who is subscribed, they are share this video with other 9th standard students of your friends, which is another class. You share this video and say them please subscribe this channel. Okay, stay home, stay safe, bye.